Hello, my name is Morris Myer. I came into politics by a roundabout way. Our local congressman was helping the cement companies pollute our community by putting toxic waste and medical waste into their kilns. I ran for Congress against him, and in January I was asked to be part of the climate project, by Al Gore's climate project. And in January I went into Nashville and learned the science and the solutions to global warming, and learned to give the presentation from the movie An Inconvenient Truth. Everybody believes that their family is the most important thing, and when we expand that circle into our communities, everybody believes the heritage of our community is an important thing as well. And when we expand that to nature and the world of the environment as large, we understand that our natural heritage is worth supporting and worth protecting, and that's one of the reasons I'm doing this. This is the first picture of Earth that was taken from outer space. This was taken in 1968 as the Apollo 8 astronauts circled around the globe. This was the first picture that we got to see of our fragile planet, and it shows our natural heritage. The next day in the New York Times wrote that we are all riders of this world together. And it's one of the, this is the only world we're going to get, and this is why it's very important to protect it. This next slide is the last picture of Earth taken from space. It was taken in the last Apollo mission between the Earth and the Moon. This is one of the most famous pictures. If you see a picture of our world, this is probably one of the most famous pictures that's ever been taken. And this is the first home movie shot from space. This is a picture that Voyager took on its way out to the outer reaches of our solar system. And this 24-frame shot basically shows our spinning world in one small day. And one of the things that the Climate Project tells us is that by opening up our awareness to our world, we can see what's happening to our world. And in the 1970s, scientists still believed that continents could not move. And this recent animation shows that the continent of South America used to be bonded to Africa. And until the 70s, it was still believed that these continents were static, that they didn't move. And one of the problems with creating a better awareness to global warming is giving folks the understanding that our actions have an effect to the planet at large. And so, what gets us into trouble is not what we don't know. It's what we know for sure that just ain't so, and we're having an effect on the planet, and we've now come to the awareness that we need to make an effort towards fixing that. This is a picture of our atmosphere taken from space. This small band of atmosphere is what sustains life on Earth. If the Earth were a 1-meter ball, our band of atmosphere would be 1 millimeter on top of that ball. Or as Carl Sagan said, if it was an orange, it would be the one layer of varnish on top of that orange. And this fragile band of atmosphere is what sustains us, what keeps our Earth in a temperate environment, and provides provides the atmosphere for every living thing. Essentially, what happens with our atmosphere is that solar radiation goes through the atmosphere and starts warming the planet. Most of this radiation is absorbed by the Earth and it warms it, but some of the radiation is reflected back into space. And some of that radiation is captured by this small blanket that bands our Earth and is used to warm our Earth. Of the warmth that our Earth has, 1/3 of the warmth comes from solar radiation, and 2/3 of that radiation comes from the reflection back down from the global warming blanket of carbon dioxide that surrounds our Earth. And what's happening is the way we're living our lives, and the way we're powering our cities, and the way we're powering our cars is adding more carbon dioxide to that warming blanket around our Earth. And that's changing the balance of CO2 in our Earth, and it's starting to thicken our atmosphere. And so what's happening is that we're getting extra warming from that thickening of our atmosphere.
Global warming, or None like it hot. You're probably wondering why your ice cream went away. Well, Susie, the culprit isn't foreigners, it's global warming.
Global wobble?
Yeah. Meet Mr. Sunbeam. He comes all the way from the sun to visit Earth.
Hello, Earth. Just popping in to brighten your day. La 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 la. And now I'll be on my way.
Not so fast, Sunbeam. We're greenhouse gases. You ain't going nowhere.
Oh, ah, oh, ah, oh, God, it hurts.
Pretty soon, Earth is chock full of sunbeams. They're rotting corpses heating our atmosphere.
How do we get rid of the greenhouse gases?
Fortunately, our handsomest politicians came up with a cheap, last-minute way to combat global warming. Ever since 2063, we simply drop a giant ice cube into the ocean every now and then.
Just like Daddy puts in his drink every morning. And then he gets mad.
Of course, since the greenhouse gases are still building up, it takes more and more ice each time. Thus, solving the problem once and for all.
But
Once and for all!
Now that's a little bit of a simplistic explanation, but it at least captures the fact that the sunlight is being caught in this band of global warming gases, and we've been able to take a measurement of the CO2 on a mountain in Hawaii, and that's far away from industry. And what we found is this sawtooth pattern that's increasing over time. We started measuring CO2 very precisely in the early 50s. A man named Roger Revelle was at the forefront of this science, and what they found is that essentially the Earth inhales and exhales from season to season as this, and essentially is on a collision course upward with higher CO2 concentrations. And the reason it's inhaling and exhaling is because when you look at the world, we've got less land mass in the southern hemisphere, less vegetation to take in carbon dioxide, and we've got more land mass in the northern hemisphere. And so when the sun is pointed to the northern hemisphere, that lowers the concentration of CO2 in the atmosphere. And when the sun is pointed to the southern hemisphere, when it's winter up here in the northern hemisphere and summer down in South America and in Australia, that actually gives us a higher concentration of CO2 in the atmosphere. And so from the 50s, they've measured the steady drumbeat of progressive increases in our CO2 levels. And what we've been able to notice is how that increase in the band of CO2 in our atmosphere has caused our world to heat up. And one of the ways we've looked at that is by looking at the glaciers. They're large masses of heat. They move slowly. They basically give us a long-term picture of our planet's climate. We've noticed in Kilimanjaro in 1970. Covered with ice, and in 2000 it's almost clear of ice. And in 2005 we essentially have a few ice cubes at the top of Kilimanjaro. In Boulder Glacier National Park, the Boulder Glacier during the time of the Great Depression and during the last year of Ronald Reagan's presidency. Portage Glacier in Alaska before the First World War, and recently in 2000, completely devoid of ice. And glaciers are large masses of cold. They're large masses of cold, and they slowly change, but that change has been noticeable over time. And day in, day out, year in, year out, these glaciers are calving as they shed ice, as they warm up, as cracks develop, and the ice calves off of the main body of ice. And we've seen in the Columbia Glacier in Alaska, essentially a progression up into the mountains that the glacier has wasted away over the last 20 years. in Torino, Italy, and recently. The Uppsala Glacier in Argentina, right before the Great Depression, and recently. Switzerland, recently. And glaciers aren't just nice to look at and nice to vacation to, they're actually very, very vital for our water supply. We've seen the Himalayan glaciers are at the center of about 40% of the world's water supply. And as the Himalayan glacier wastes away, that's going to present water shortages for over 2 billion people. And this is why the climate change that global warming has brought about has dramatic and drastic impacts for our planet. One of the things we've been able to research is how these ice cores and how the ice has changed over time. Scientists like Lonnie Thompson from the Ohio State University have drilled into the glaciers, and they drill down into these ice cores, and what they find are essentially year in, year out datings of how much snow and how much ice fell year by year, and it's similar to the tree rings on a tree. If you cut down a tree, what they do is they drill from the top down to the bottom, and they get thousands and thousands and thousands of years as they go down. In the Antarctic glacier, you've got 3 kilometers of ice, over 1.5 miles of ice that the scientists are drilling down, and they've actually been able to extract a good record of both the temperature and how much carbon dioxide is in the ice in the little ice bubbles from their ice cores. And what they've been able to find is that over the last 1,000 years or so, in the northern hemisphere, basically from checking out these little ice bubbles in these ice cores, that we've seen a 1 degree rise in our global temperature, and they've been able to correlate this rise of CO2 and the rise of global warming, the temperature and the carbon dioxide concentration. And as the carbon dioxide has gone from 280 to 380, we've also seen an almost 1 degree rise across our world. And they've actually been able to go back hundreds of thousands of years by drilling through some of the thickest glaciers. And we have over 650,000 years of ice core data that shows us essentially how the carbon dioxide concentration has varied over time, and how the temperature is correlated over time. And essentially, as one goes up, the other goes down. The other goes up. And we see a very close correlation to temperature and carbon dioxide. Now, the difference between 180 parts per million and 280 parts per million is the difference between a nice spring day in Central Park and having over 1 mile of ice on top of your head. So you might ask yourself, all right, well, what are we doing now with our carbon dioxide concentration, and what effect will that have on our global planet climate system? Our current climate concentration is way up at 400 parts per billion, and that's where we are currently. And you might notice that this is way outside of our historical record for carbon dioxide. We are outside of what we know to be normal for our planet's climate system. And if we don't do anything about it, in 45 years, our concentration will be 600 parts per million, almost double what the planet normally holds. And so what we've seen is we've been able to collect temperature readings from across the planet for over 150 years. And what we've seen is that we've seen over a degree of change in our planet's climate system, and the 10 hottest years on record have occurred in the last 12 years. And the hottest year on record was 2006. Okay. 2000 saw the hottest year on record. And in 2003, we had a giant heat wave in Europe This is a picture of the Munich Zoo. We saw heat that was far outside of the norm. If you've ever vacationed over in Europe, you know they have a passing fancy with air conditioning. My wife and I were in Paris for our honeymoon, and that the air conditioner basically thought about blowing cool air, but wasn't really effective at it. And we had tens of thousands of dead folks die in that heat wave. Temperatures were Texas normal for the rest of Europe. And in the United States, we saw above normal or record warm temperatures all across the continental United States. And for the period of July 2005 through June 2006, it was the warmest on record that we've ever measured. We had heat wave on the eastern side of the country, records in Newark, Florence, Raleigh-Durham, La Crosse, Wisconsin, and on July 25th, the airport in New Orleans gave us an all-time high, and we've seen increasing records as time has marched on. And what we found as we've looked at the ocean temperatures is that we've seen a predicted variability. It's still along the axis. It's stable along the axis and not increasing. But with the increasing warmth that the air is putting into our climate system, the model that they expect to have is that the ocean is going to get warmer. As the air gets warmer, the ocean gets warmer. And as they've actually measured that the observed temperatures are within what they expect, and so the ocean has actually climbed up as well. And what that means for our planet's climatary system is that there's more moisture in the air and there's more energy in the ocean system. And that means larger storms that have more punch because they're carrying more weight in terms of the wind. When the wind hits buildings and that kind of thing, the wind actually carries more punch because it's more moist. And so we've seen very powerful hurricanes like Francis, Ivan. We've also seen record storms in Japan. We had a record set for typhoons in 2004. In Brazil, something very unique happened in the course of our recorded weather history. We had the first ever hurricane in the South Atlantic. We had to rewrite the history books. They didn't expect that hurricanes could ever form in the South Atlantic, but we got the first one in March 2004. In 2004, we also saw a new record for tornadoes, and this year in the United States, we're on course for a heavy year as well. We saw in the summer of 2005, we had a banner year where we had 3 hurricanes at once in the North Atlantic. Hurricane Dennis steamed into the Gulf of Mexico, caused great damage. You know, these oil derricks are just not supposed to be under bridges. And what they found is that in 2005, they had a study right before the Katrina disaster where they saw that the intensity and the duration of the storms in the Atlantic and the Pacific have increased by 50%. The intensity because of the weight of the water in the air, and the duration because of the extra energy in the ocean's climate system. And so what they've been able to measure is that what insurance companies actually found out that as the water temperature goes up, the wind velocity goes up, and the storm moisture content goes up as well. And they've actually measured that it's a square proportion. It's not a square proportion, but a cube proportion. And so late in the summer of 2005, we had a very, very warm Gulf of Mexico, and that led to the formation of one of the most powerful hurricanes to ever hit the United States, Katrina. And you can see the massive eye steaming on shore a little bit east of New Orleans. And Hurricane Katrina woke up a lot of Americans that essentially the era of procrastination, of half measures, of soothing expedients and delays is coming to its close, and we've entered a period of consequences. Our period of consequences is that the way we live our lives, the way we power our lives, is changing the planet's climate system. Later on in September, we had Hurricane Rita, In October, we had Hurricane Wilma. And this is one of the strongest hurricanes that was ever measured in the Atlantic Ocean. And typically they go through the alphabet. You go partway through the alphabet. Some years hurricanes are named after men, some, like Hurricane Andrew. Some years hurricanes are named after women. But what happened after we got to the W's is that for the first time in recorded history, we ran out of alphabet. And essentially we had to go into the Greek alphabet and Tropical Storm Alpha, followed by Beta, Gamma, Delta, Epsilon, and then finally on the last day in 2005 we got to Tropical Storm Zeta. Now we didn't only get through the alphabet of names, we got completely through the alphabet of Greek letters, which was far outside of the norm that we can expect for climate. And what we've seen is that climate is what we expect, and weather is what we get. And what we have done is we have changed the expectations of how storms interact in our oceans. And what the insurance companies have seen is that the increased the intensity, the increased duration, has led to almost a catastrophic uptick in terms of their loss. And the Lloyd's of London, which is a very austere organization in the insurance industry, they've said that if this keeps up, the insurance industry will be extinct. And it's not only hurricanes, it's not only tornadoes. What we've seen is extreme weather events all across the world. Japan has had a heavy number of rain downpour events. Switzerland in Europe had a flood that they said was as catastrophic as any as they'd ever seen. They thought it was something out of the book of Revelations. And Europe has seen major flood events. Asia has seen an increase in major flood events. And in Mumbai, India, in one day in 2005, we got over 3 feet of rain. We got 7 feet of water, 1,000 people dead. And the next day, 4 million people commuted in a very wet rush hour in one of the worst weather events in their history. In China, which has many thousands of years of recorded weather history, they've seen record flood events. They've seen record drought events. And the interesting thing is that the floods and the droughts are right next to each other. And what the global warming has done is the increased warmth is starting to parch the water out of the ground. And in Darfur, one of the problems is that the lake that used to sustain agriculture in that area has now dried up, and it's adding to a complex crisis point already in that region. And what essentially happens with global warming is that the added warmth takes moisture from the ocean. It's that added evaporation takes moisture from the ocean, but it also takes moisture from the land. And so what happens is that increased moisture capability in the clouds are very heavily laden with moisture. What that leads to is flood events that are right next door to drought events. And what we've seen on one of the largest rivers in the world, the Amazon River, is it's dry. And this is going to hit home here in America in our breadbasket. We've already seen drought conditions in the American West, but we're also going to see in the breadbasket, we're going to see a reduction of the soil moisture, which is going to affect our food production. And with doubling of the carbon dioxide, we're going to lose up to 70% of our food production in the United States. And so with a quadrupling of CO2, the soil moisture will look like our breadbasket of the United States could look like this. So what I'd like to do next is look at some of the canaries in the coal mine. Essentially, the scientists have measured glaciers in terms of the long-term record of climate changes. And these glaciers have stayed around for many millions of years, and they're a large thermal mass. So they're one of the leading indicators in how we change, how the climate is changing. And what they found in Antarctica at the top of the world is, for the first time in recorded history, they have a split in the Antarctic ice pack. Around Antarctica in the Arctic, around the Arctic Circle in the Arctic. We've also seen warming of the permafrost and melting of the permafrost that's led to vast stretches of forest, giving us what they call drunken trees. They basically lose their footing inside what was normally permanent ground. We've seen crosses come out of their holes because the ground is no longer permanently frozen, and this is something they depend on to transport cargo across the Arctic. And what's happened is that melting ice has caused a vast transportation problem for traveling across the Alaskan tundra. One of the best parts of ways that we've been able to capture data for the ice comes to us from our United States Navy. During the Cold War, our submarines used to use sonar to figure out how thick the Arctic ice was, and when it was less than 3 meters thick, our subs could get through and send out either a distress beacon or be updated with the conditions of the security conditions of our country. And they've had long-term data of the sea ice extent in the Arctic Circle, and essentially for the last 100 years, we've seen a marked decrease in the number of the amount of area that's covered by sea ice. And what's essentially happening is a forward feedback loop. Essentially, the color of the ice is changing as more and more ice melts. You have less ice surface and more water surface, and that water surface is darker, picks up more sunlight, and further melts the ice. And basically the cycle completes and accelerates. And what's happening is essentially the air conditioner at the top of the world is going away. And that's a problem for our friends, the polar bears. The polar bears actually look for holes for seals to swim up through, and that's how they find their dinner. And when more and more ice breaks apart and is melting, the seals have plenty of places to go breathe from, and the polar bears have more area to look for for their evening meal. And so what's happening is that over time, our Arctic Circle is melting, and we're losing this large, radiant, reflective area in our global climate system, and it will no longer be able to cool off our planet. And what's going to happen is that will permanently alter our North Pole climate system. What we found is that the Earth is a nonlinear system, and that means that the warming that we've seen does not get spread evenly out across the surface of the globe. Essentially, the Earth is a heat engine, and it tries to move heat from the equator up to and cool off that heat towards the poles, and that's why I'm saying the Arctic is actually is an air conditioner for the Earth. And in 2004, the average temperature of the Earth was 59 degrees. And what the recent climate reports from the Intergovernmental Climate Change Committee, they said that we're looking at between a 2 and a 5 degree temperature change over the next 100 years. And what a 5 degree change actually means that we're going to see a 1 degree change towards the equator and a 12 degree change up towards the poles. And we don't know, based on the currents and the nonlinear model that our climate takes on, we don't know which currents that's going to change. One of the things we think is going to change is what's called the global conveyor belt. The global conveyor belt is a belt of billions of gallons of water that gets transferred across the ocean, and is essentially as this red band of water, which on the eastern shore of the United States is called the Gulf Stream. The stream of water actually, as it evaporates and comes back down, causes a lot of moisture to be warm moisture to flow eastward across Europe and provide a pretty moderate climate for Europe. And so cities that like Madrid is actually on the same is on the same latitude as New York, but it's actually much hotter. London and Paris are actually at a latitude that are north of Fargo and Montreal, and they're actually much warmer than Fargo and Montreal. And so this climate system, as it's changed, is susceptible to large bodies of water changing it. And in the recent ice age, the last ice age, we had a melting pool of meltwater as the glacier melted, and as that came out through the St. Lawrence Seaway, that actually slowed down and stopped the Great Ocean Conveyor, and we saw a little ice age in Europe. And our scientists have said we cannot preclude that we will stop the North Atlantic Ocean Conveyor in the 20th century because of global warming. Now, the second canary in the coal mine is actually the Antarctic. It's home to penguins. They're already in trouble. And they've said that one of the great warning signs of breakup of the ice shelves will be visible as time goes on. And we've seen in the West Antarctic, the western part of the Antarctic has been very susceptible to global warming, and we've seen large portions of the Larsen ice shelf break off year by year. And by large, I mean about the size of Rhode Island. So these are state-sized chunks of ice that are calving off from the largest body of ice on our planet. And this body of ice actually has the western Antarctic ice shelf. If it were all to melt and slough off into the ocean, we would see 20 feet of ocean rise around the world. And so what we've seen is these little dark bands are actually pools of water, little moulins of water that are melting through the cracks and going down to the going down to the ocean, going down to the base of the glaciers at the ocean. And the Antarctic is one of the largest sections of ice in our world. It's actually 2 to 3 meters thick. We've got 1,000-foot cliffs of ice. In January 2002, they started to notice the Larsen ice shelf breaking off and large sections of ice basically rushing out to open ocean. And the problem with the ice in the Antarctic is that it's up on top of land, and so that water is suspended above the land. And as the ice comes off the land into the ocean, it actually raises the level of water, and that's providing a problem for lower-lying ocean nations like the Maldives. And their barrier walls are being stressed more and more as time goes on. The British, London is actually pretty close to the sea level, and this train route that was almost 100 years old is now being is at danger by being overtaken by the ocean. The British have great barriers in the Thames River, and when the ocean levels get higher, we've actually seen closings of the Thames, and that the number of closures of the Thames River has gone up as we've seen more and more water in the ocean, and we see more energy in the ocean's climate system. Now, the West Antarctic, what I've said is that we have over 20 feet of water. If the Western Arctic were to break off. And we also have another additional 20 feet in Greenland. If Greenland were to melt, we'd also see another 20 feet. So we're talking about many meters of water that would inundate our coasts. And What we've seen in Greenland is very similar to what we've seen in Antarctica. These moulins are actually pools of meltwater on the top of the surface. And as these pools gather, they go through cracks and they get down to the bottom of the glaciers, and they allow the glacier to break apart and hydroplane its way out to the open ocean. This is one of the parts of our climate system that's not very well understood, but they understood it well enough to know that we're seeing more and more of these what we're calling glacial earthquakes. Glacial earthquakes are essentially what happens when these large glaciers kind of bebop their way to the ocean. In 1993, we saw 6 glacial earthquakes, and over the next 6 years, we saw a doubling, and that doubled again over the last 6 years. And so we've seen the seasonal ice melt change in Greenland as well. So that we understand that we're seeing more tropical weather, if you want to use a term like that, for Greenland. In 2002, we've seen larger sections of Greenland being exposed to ice melt. And in 2005, almost half of the island of Greenland has undergone ice melting. And what they've said is the maps of the world are going to have to be redrawn. In Florida, as the oceans rise, we're going to start to lose vast sections that are very close to the ocean. In San Francisco, in the Bay Area, we're going to see over 1 million climate refugees as the water rises in that area. In the Netherlands, we're essentially going to lose the entire country because of the rising oceans. In Beijing, we're going to see 40 million climate refugees from the area. And in Calcutta, India, we've got almost 40% of the nation of India that live within a meter or two of the water of sea level. And this is not only going to affect folks far, far away. In Virginia, in the Delmarva area, we're going to see large sections of what we know to be our natural heritage slowly and surely become subsumed to the ocean. And these aren't going to be folks, the nameless folks, a world away. These will be our friends. These are going to be our neighbors. These are going to be our relatives here in Virginia and Maryland and D.C. And so we were witnessing a collision between the civilization and our Earth. And what we see are there 3 factors that cause this collision. The first is the population explosion. Second, our technical revolution. And third is our way of thinking. Population growth through history. We've gone from the Adam and Eve 160,000 years ago to, or the first modern humans, to a quarter of a billion people around the time of Christ, a billion people around the time of Columbus discovering America, 1 billion people around the time of the Revolution, little over 2 billion after World War II, 6.5, almost a tripling currently, and we're looking at almost 9 billion people by the middle of the century. And what's happening is essentially our developed nations are stable. And the reason this is because we have health care. Our parents, our families have health care for their kids. We've got good access to medical care, and we don't have to have 12 kids so that 3 survive. In developing nations where they don't have access to good health care, parents have more and more kids because they want to make sure that a few of their children survive. And so as we put additional population pressure on our planet, we're essentially causing great destruction to large tracts of wilderness. And our policies make a difference. What we've seen in the Dominican Republic is different than what we see in Haiti. This is the Dominican Republic, and these are good land use policies. And in Haiti, where they haven't put an effort towards this, the result is very visible from the air. In Brazil, almost 30 years ago, the rainforest was untouched. And a couple of years ago, we can see that we're having a large, very, very visible effect on our environment, and we're basically burning down parts of Brazil to turn it into either sugarcane or grazing land for meat for our McDonald's hamburgers. And so we see that we're having an effect on the planet. And so what we can see from a global satellite is that essentially we're burning up parts of Africa for fuel for cooking stoves. We're burning up parts of South America to clear for new farmland. We've since stopped doing that. We've got electric lights that are basically lighting up our planet for space, and these yellow lights are actually oil and gas wells in Kazakhstan and Russia that are burning off their methane. The reason we don't see those in Texas or Saudi Arabia is because we've got newer technology. And you can see the blue are the ocean fishing fleets offshore. And essentially, our scientific technology has opened up a vast new world of influence that we're actually becoming more and more influential upon the planet's surface. It's brought us medicine, it's brought us communication, and then what we've seen is that old habits plus old technology equals predictable consequences, and old habits plus new technology gives us dramatically altered consequences. So, as technology has changed, we've seen that technology have an effect on the planet as well. Weapons, started out with spears in the Grecian era, to muskets and bayonets in the Revolutionary era, to still machine guns and in the World War II. But we've seen a tipping point for technology in weaponry at the end of World War II. Where we saw that human beings had the potential to wipe out life on our planet, and so we've seen shovels change from the human-powered version to mechanical to planet scraping, the size of a small city eventually, and that has given us the ability to vastly change our landscape. Nets like this used to feed cities feed small towns for thousands of years, but as technology has progressed, we've seen drift nets that are many miles long that are scouring the oceans for ocean life. We recently saw a report that in 2048, the ocean will be completely extinct, that all species of fish will be completely extinct from overfishing. Irrigation is a wonderful thing. It's it's giving us a breadbasket that's allowing us to export food, but that's causing some changes in our planet. Colorado River used to be a wide river heading out to sea, and now it's a creek by the time it gets to the open ocean. And so human beings are now the most powerful force of nature. We're the largest force of nature. And essentially, we've changed. Our contribution to global warming is changing our planet. Essentially, we in industrialized nations, that the United States and Europe are the prime contributors to global warming. And when you look at the emissions per person in Africa and India and China, their economies are certainly not as far along as we are. But the developed nations, and then the United States, we've got a large footprint. We're the 7-Eleven big gulp of the industrialized world. And even when you account for the amount of emissions per country, taking out the per capita and including the larger population for China and India, that changes the balance dramatically. But the United States is still the #1 contributor to global warming across the world. So our third factor is now our way of thinking. The light bulb moment is whether we can change, whether human beings are causing change to the planet, and we are. The first of three misconceptions is there a disagreement among scientists whether this is a problem or not? And we have found that recent Science magazine has said that consensus as strong as this one has developed. It's rare in science. James Baker of the NOAA has said that there's better scientific consensus on this than any issue I know, except maybe Newton's second law of dynamics. And so they did a study of the number of scientific papers dealing with climate change that have been published during the previous years. And out of 928 papers that were published that deal with climate change, the number that disagree that greenhouse gas pollution has caused the warming for the last 50 years is 0. There's complete consensus in the scientific community. Now, there's a misconception about the science, and that misconception is deliberately caused by those who oppose government action. And their objective, as leaked to the press, is essentially to reposition global warming as theory rather than fact. The science is just not out. Well, the science is in, and it's a very as uniform of a consensus as we've ever seen, and we've seen this before. We've seen sort of this smoke screen that has been, that sometimes people with ulterior motives have raised to try to change public policy. We saw this during the tobacco smoking era, where we thought that smoking was actually good for you. And they postponed a real close look at the science behind tobacco smoking. Now, have they succeeded? Well, we saw that out of 928 peer-reviewed scientific articles, 0 were in doubt as to the cause. But in terms of articles in the popular press, we see over half of people think that there's still doubt as to the cause of global warming. Now, no wonder people are confused. So, do you have to choose between the economy and the environment? This is a slide from the first Bush administration where we have to basically choose between gold bars and the environment. Do we have to hurt our economy to help the environment? Well, the Stern report has actually said that if we don't do anything about global warming, we're going to see a 20% impact in our world GDP, and that to do something about global warming and avert it will take less than 1%. So it's actually an ounce of prevention is worth a pound of cure. A company like Walmart put $500 million into conservation, and their period of payback for this investment is 23 months. So that after 23 months, they're making money on doing the right thing for the planet. It's actually making them very good money. And so what we see is that driving more efficient cars is actually a good business. And for Japan and the EU and Australia and Canada, we're essentially at the bottom of the world's automobile makers in terms of efficiency. And in California, we're doing a little bit better, but essentially we're playing catch-up ball with the rest of the world. And in terms of the number of cars that get sold in Europe that get over 40 miles per the gallon, there are over 113 models that get over 40 miles to a gallon. And there's only 2 in the United States that get over 40. And so this has given us a good look at what green means to the world automobile market. Toyota and Honda have had record profits and record record growth, and GM and Ford have seen their tide turn. And so businesses have looked at this. They've looked at the change that's on the horizon, and one of the largest energy companies, the CEO of Duke Energy, has said, personally, I feel that the time has come to act. The CEO of GE has said green means green, and it's a profitable thing for them. GE is one of the makers of the world's largest wind turbines, and it's a booming business, and it's an export business for our country. And Linda Fisher said that it's a very good thing to work towards green. And Lee Scott of Walmart said the science is in, And he believes it's their responsibility to reduce greenhouse gases as quickly as they can. So, the third misconception is if we accept that it's real and that we're causing it, is this so big that we can't fix it? Well, we've already fixed large problems in our world before. And our scientists have looked at this, and they've looked at what we need to do, and we already possess the fundamental know-how, the technology to fix this problem within the next half century. Within our automobile fleet, it's switching to hybrids. Within how we power our houses and how we power our cities, we can switch to wind, solar. We can create more renewable energy, which is a fast-growing field here in the United States. And essentially, we can turn this picture of increasing greenhouse gases well off into the future. We can start to change that slope. We can start by concentrating on end-use efficiency of electrical appliances, better dishwashers, better light bulbs, switching to smart bulbs, compact fluorescents. We can work towards other end-use efficiencies in terms of our building codes, by creating greener buildings, by insulating, by having office buildings that turn off their lights after everybody's gone home, by working towards better passenger vehicles, by working towards hybrids and plug-in hybrids and electrical vehicles, by working towards transportation efficiency, by moving freight by rail instead of by 18-wheelers. By investing in renewables and moving the way we power our country from coal to wind and solar and nuclear. And by also investing in the carbon capture and sequestration technology that puts a cap on top of our coal plants and takes the carbon dioxide out of the emissions and sticks them and puts it into the ground. And by doing that, we actually get down far lower than we were in 1970. We have the technology today. It's actually good for business. It's good for our environment, and it will put the United States at the forefront of an advanced alternative energy industry. And what we've done worldwide is that we have the Kyoto Protocol. And the Kyoto Protocol was our first step towards trying to address this situation. The Kyoto Protocol has been ratified by every nation in the world except the United States and Australia. And we have our own individual states that are taking the lead on global warming. And one of the things that I'd like to do as I'm running for the House of Delegates in an election this November is work towards taking the issue of global warming to Richmond and giving leadership in terms of our climate policy for how we move our state towards cleaner and greener sources of fuel. We've been taking action on our cities. We have hundreds of cities in Arlington, Virginia as one of them, that are also supporting Kyoto and lending the sort of momentum towards doing something about climate change. And the United States has addressed great problems before. We've taken on tyranny. We are the longest running democracy in the free world. We are the crucible of democracy. We threw off the bonds of slavery. We gave women the right to vote. We tackled tyranny in World War II and defeated fascism in 4 years. We cured polio. We dealt with some of the most contentious issues in our society with the civil rights movement. We dealt with apartheid. We dealt with the falling of communism. We put a man on the moon, and we actually have taken on a global weather problem and together, and we've actually addressed that, and we've had success with that. A couple of decades ago, the issue of the ozone hole was a very pressing one, and we had a vast ozone hole over the Arctic and the Antarctic. We basically took action to change out our compact fluorocarbons, and we worked to reduce those fluorocarbons in our society. We worked with other nations, and by the end of the 90s, we actually we minimized our chlorofluorocarbons and changed into new technology. And one of the ways we can act is essentially by taking advantage of our voice. We can raise our voice in the political sphere. We can talk to our local congressmen. We can talk to our local representatives. We can talk to our city councilmen and women. We can talk to our mayors. We can raise awareness in our churches. We can raise awareness in our civic organizations, and take this from not a personal choice but a community choice. And finally, we have to remember that we're all on this world together, that what we do in terms of our effect on this planet has a global an effect worldwide. And so as Voyager went out to the edge of the solar system, they turned around the camera for Voyager and turned it around and panned it around to Earth. And this little pixel, this little tiny dot, is the Earth from the edge of the solar system. That's all our hopes, that's all our dreams, it's our wars, it's our art, it's our politicians and farmers and parents. It's our hopes and dreams. It's this little ball of dust that's the only planet we're ever going to get. And as we understand that we have to take advantage of this challenge, this is a moral obligation for every man and woman to take on. So I thank you for watching, and you can go to our website www.morrismyer to find other ways that you can address global warming and how you can get involved in taking on this challenge. Thank you.